Alright guys, here we go. This is Samantha Stanley, and this is my first instructional video for the year. I wanted to go over integration by parts. I really like this concept because it's a great way for us to be able to solve intricate integrals that we otherwise might not be able to solve. So I chose this example because it's fairly straightforward, but still covers the concept quite well. It also doesn't give us any super crazy numbers, so it helps to demonstrate the topic without getting too complicated. So right here you can see that our original equation was to integrate x squared cosine of 7x dx. So what are we going to do first? Well, if you look right here, we have our equation to solve through integration by parts, and we have the integral of u times d of v equals u times v minus the integral of v times du. So the first step that we want to do is we want to identify what terms we have here. So we need to identify u and dv. So what I've done is I've chosen u equal to x squared and dv equal to cosine of 7x dx. I kind of just chose these because I choose the first term and then the second term. So first term x squared, second term cosine of 7x dx. Pretty straightforward. I found the original equation for v. I'm going to assume that you guys can kind of reverse the integration here. Not the integration, I apologize. Differentiating the equation. So I assume that you can do that, but nonetheless, v is equal to 1 over 7 sine of 7x. And then I take the derivative of u, and I get du is equal to 2x dx. Alright, so moving on here, our first step is going to be to rewrite these terms in terms of this equation right here. So we've got u times v minus the integral of v times the derivative du, So the first thing that I like to do is I like to kind of take care of this step right here, the u times v. It's pretty easy, straightforward. So we have u times v is equal to 1 over 7x squared sine of 7x. I just rewrite it because I like to have that constant out front, because when you deal with integrals, you can move that constant outside of the integral sign, and it just kind of keeps everything together nicely. I apologize for the number of pages, but that's the way this works here. So now let's deal with the integral part of this. So we have negative the integral of 1 over 7 sine of 7x times 2x dx. So what we're going to do here is we can't really deal with this integral without actually doing integration by parts again. So even though it's not, my brain kind of views it like the chain rule. But not like the chain rule, but in the sense that we have to keep doing it till we get where, we have something that we can actually use. So what I just did here is I multiplied the 2x with the 1 over 7, and I brought both of those terms out to the front, so we get negative 2 over 7, the integral of sine of 7x, 7x times x dx. So I lied. I didn't bring the x out. It stayed there. So now this integral looks a little bit more familiar to us, and it looks like we can use the integration by parts. So what we're going to do now is the same thing that we just did. We're going to identify the terms that we have in terms of the original equation, u times v minus the integral of v times du. So here we have u of x again. I switched it up and I used the second term just to give it a whirl. And dv I have equal to sine of 7x dx, as you can see. And then I find the derivative of u, which in this case is just dx. Although I might be wrong, this indicator right here tells me that I'm probably going to be able to do something with this, and this might be the last time I have to do this integration by parts. But we'll see as we go on. Anyways, I find v again here, assuming that you guys can do that. And it's negative 1 over 7 cosine of 7x, because if we take the derivative of cosine of 7x, we get sine of 7x dx. Alright, so now that we've found those terms, we can use integration by parts to solve. Or can we? So because I brought the constant, the negative 2/7 outside of the integral sign, I've put that right here. And I have my u times v, x times negative 1 over 7 cosine of 7x, minus the integral of 1 over 7 cosine of 7x dx. So what I did is, because this was outside of the integral sign, this negative 2 over 7, I have to multiply it through to each term. Can't forget about that. That's a very vital part. So again, we have the u times v term right here. So I'm just going to solve that one right here because it's super easy. We get 2 over 49 x cosine of 7x plus negative 2 over 49 times the integral of cosine of 7x dx. This right here, guys, this is our sign that we are nearing the end. This problem will soon be over because we know how to solve cosine of 7x. But right now, I've got this highlighted in red here. This is what we're actually going to use in the end to create our final answer. I kind of like to do it that way. Keeps everything separate for me as I work through each one of these integrals. Moving on, we're going to deal with our last term here, the negative 2 over 49 integral cosine of 7x dx. Well, guys, this looks easy, doesn't it? This looks like something we can solve. And all we're going to do is use substitution here. So I've let u equal 7x. Easy, right? du is equal to 7 dx. Now, I kind of approach this a little bit differently than what I've noticed the book does, and I think even Professor Dressler did it a little bit differently, he did it a little differently in his intro videos, his instructional videos, I'm sorry. So what I like to do is I like to get du equal to 7 dx. In terms of dx, for some reason, it just makes a lot more sense in my mind to set the equation equal to dx. So right here, I've got 1 over 7 du is equal to dx. So now what I'm going to do is I'm going to plug that in for my little dx term. And I brought, actually I already have the constant outside, so I don't even have to worry about that, which is great. So I've got the cosine of u times 1 over 7 du. So I'm going to bring my constant out and multiply it again. And then I end up with negative 2 over 343 times the integral cosine of u du. So now all I'm going to do is I'm going to integrate this lovely term right here, which is super easy. Once I integrate that, I'm going to get negative 2 over 343 sine of u. Well, that's easy, right? Well, the only thing that we have to do before we move on is plug u back into that. Can't forget to do that, guys. We have negative 2 over 343 sine of 7x. So finally, we've got all these terms, and we got to do something with them. So let's just put it together. And our final answer here is going to be 1 over 7 x squared sine of 7x plus 2 over 49x cosine of 7x minus 2 over 343 sine of 7x plus c. Well, that took a while, but we got there. And one final thing, after you've worked so long and hard on this problem, make sure to put that plus c. Don't forget the plus c if this is an indefinite integral. Alright guys, I hope that I explained integration by parts pretty well for you guys, and good luck. I look forward to seeing your videos.